We're covering bone development, or ossifications, as we learn how we get to understand our matrix of bone and we develop bone. There's two types of ossification, which is a bone development: intramembranous and endochondral. We're just going to describe the difference between the two, and then we'll have more videos talking about them independently. But when bone forms, that's called osteogenesis, which is bone formation. And then once it forms, it can start to grow. And we grow bones in two ways: in width, which is appositional growth, and then in length, which is interstitial growth. But we can't grow until we have the materials to develop it so it can grow. To me, bone development is this process of ossification. We bring in the right materials, which means the right cells, to then create the right matrix to give us what we need to develop bone. Because remember, bone is only sometimes 2 to 3% of cells. It's what they develop and make to form the bone that creates the actual product that you see as a bone. So two types of ossification: intramembranous and endochondral. Intramembranous is referring to within a membrane, and we refer to this for dermal bones. We say dermal, like closer to the skin. So it's bones that I can, when I think about intramembranous, it's what I can feel. So I can feel my mandible. I can feel my frontal bone, my parietal bone. Those are bones that I can actually touch and feel. My clavicle, the right at the skin, dermal bones. And we call intramembranous ossification within membranes, and we'll talk about those membranes, but it's referring to these types of dermal bones, more of a simpler process of bone development, versus endochondral is within cartilage, and specifically it's hyaline cartilage that we use it as a model. And what happens is when we talk about ossification, the actual definition is taking one tissue and replacing it with another. In intramembranous, we take mesenchymal tissue and turn it into bone, and we use the cells to make bone, osteoblasts, and then our osteocytes to maintain it. When we look at endochondral, we're taking first mesenchymal tissue and then turn it into hyaline cartilage to create a building block to then turn that into bone. And this can take years in many cases, depending on the bone. Somewhere it's up to 25 years for endochondral, usually referring to long bones. So as we look at this, let's just talk about when we talk about intramembranous. The picture here is matching the microscope slide down here, but what we're basically saying is I have a top sheet of mesenchymal tissue and then a bottom sheet. So it's in between two sheets of tissue. Remember, mesenchymal tissue is our stem cells or embryonic tissue for which all connective tissue arises. So mesenchymal tissue is that basic tissue that then it differentiates and turns to other types of cells to give me the final product. In this case, we're talking about bone. So we'll see two sheets, one here and one here, of mesenchymal tissue that'll gradually migrate and change with the blood supply to give me the actual structure of bone. How do we do that? Well, the mesenchymal cells turn into osteoblasts. Some books will say, well, you also see Osteoprogenitor cells, which we'll talk about that in the next video. But it turns it into bone because the cells change. And because the cells change, their function changes. And what are they doing? They're secreting the matrix, which is that osteoid, to where you're getting the calcification. Calcification is creating the mineralization of the bone, specifically using calcium phosphate, calcium carbonate. So I look down below here, this dark purple is trying to show you the formation of bone, and you could start to see that it's looking more like spongy bone. So we're turning this into spongy bone. And then on the top, I have a membrane sheet of tissue, that mesenchymal tissue, and then also here on the bottom. So in between two membrane sheets, I'm creating this type of bone, and it occurs in dermal bones. Versus when we look at endochondral, this is showing you a long bone. So a lot of our long bones go through this process to where they're using now hyaline cartilage, to where we occur at the epiphyseal plate. So this section here, at the epiphysis and then the diaphysis, there's a section in between there, a region called the metaphysis, and this is where I have hyaline cartilage. This is matching on this side to where there's different zones on how it develops, but basically you're going to have hypertrophy or dying off of cartilage cells. And where do those cells come from? We start with mesenchymal, then it turns into hyaline cartilage, so we're using chondroblasts and chondrocytes to use this as stacking cells. So they call it epiphyseal plate because it's literally like we're stacking plates of cartilage that will then be replaced by bone. We're taking one tissue and turning it into another. That's an ossification. So once we're done growing, depending on the bone, like I said, this could take years, it turns into a epiphyseal line. So epiphyseal plate and line is at the point in development. A plate is when it's growing, a line is when it's finally done. So for example, some bones take a couple decades for them to actually finish their product. So what we see as a difference here is that hyaline cartilage model that we're using, and then it starts to turn into bone. So when I look at the dark purple over here for spongy bone, that's forming these dark little purple sections here. So it's very baby spongy bone that we're looking at. So intramembranous and endochondral ossifications is understanding how do we get to the final product of bone. We use our cells to create the matrix, but we can't do that without a foundation. We both start with mesenchymal tissue, and then it just depends on where we're at, which bone. Are we just using mesenchymal, turn that into osteoblasts, osteocytes, or are we using hyaline cartilage as a model? This is intramembranous and endochondral ossification. In the next couple of videos, we'll break down the two and just go the order of the steps of the cells and how they differentiate.